This Flexvolt, DeWalt Flexvolt 60 volts, 20 volts, 9 amps is not charging. So I'm going to investigate what's wrong with it. There are already signs of water damage and other things, but I'll now open it up. I took out these 4 screws that go here and prying up this on the inside. Oh man, that's corrosion. May not be the end of the world, but it's definitely a bad sign. I'll take out the other side too. I've done some basic cleaning of that oxidation and water damage and so on, just to see how the connecting board looks like. Don't see anything immediately wrong, interrupted, burned or something. This rust here is not the end of the world, because as long as it still connects the batteries, it should be fine. Anyway, I'll continue on the other side. The other side, exactly the same problem, and probably even worse. So anyway, I'll try to clean this white stuff and rust and so on, so that we can see what's underneath. I mean, it may be that this battery is just something I'll crack open and try to extract all the cells, but I haven't given up yet. And this is a view from the top after taking off the top. It's as if this battery was submerged in water. Anyway, it's as bad as it gets, unfortunately. So initial charge between the plus and the minus was 6 volts. Nothing was charging, so I soldered the wire here and I connected through a watt meter a 12 volt charger. Initially it flickered between red and green, but then it managed to raise the tension to 11 volts and now it's charging with 830 milliamps, so almost 1 amp. So I'll leave it to charge until it gets to the maximum of this 12.8 voltage, and then I'll switch it to another charger that's a 20 volt charger, lithium charger. It may be possible if I connect it right now to the 20 volts, it may start charging. But the difference in voltage is too high, so I'm gonna go slow. But still raising, so that's good. It means some of the cells are good. So now I'm just monitoring the charge. It's at 11.7. Sorry, 11.17. But it's still going. And using the voltmeter, interesting. Normally between individual batteries, if you try to measure, you get some sort of measurement, but now no matter which point I measure, he gives me this 11.2 voltage. Let's see between these points. 4.1. Yeah, the measurements are interesting. I still can't yet figure out what I'm measuring here. Well, the voltage is getting maybe a little bit higher. Even though it seems like it's accepting charge, but not really showing an increase. I'll probably have to study some more. After cleaning these connecting boards, if you see, there are some soldering points called T1, T2, T3, T4, T5, all the way to T7 on this side, and I think it goes up to 16 on the other side. So let's try to measure with a voltmeter some of these points. So if we measure between T1 and T2, this should be between two batteries, I think. 6.7, that doesn't look right. T2 and T3, 0. So probably that's why it shows 6 point something. Maybe this battery is shorted. Between T3 and T4. Where is T4? Oh, here. T3 and T4, again, nothing. Between T4 and T5, 1.8. So this may be a discharge battery, but nevertheless may be usable. T5 to T6. Yeah, discharge 1 volt, but maybe usable. T6 to T7. 0. So a whole bunch of cells here that are broken. Now on the other side, T7, man, this one is really dirty. Okay, T7, what did I say here? T6, okay. T6 to T7, this one is almost good, 2.5 volts. T7, T5 to T6, good. T5 to T, I think this is T4. Okay. T4 to T3, T3 to T2. Oh, this one is great. And T2 to T1. Interesting, on this side, all of them are good. Yeah, we have to do more investigation. So after the measurements, I connected a 20 volts charger. It's now charging at 600 millivolts, and I also put a voltmeter in parallel to the plus and the minus. Based on my measurements, I'm almost certain that some of these rows of cells are shorted, so I may have to open it, and because of the soldering points, it's gonna probably very difficult to lift this side thin film to get to the individual cells and break the spot welding connector and start measuring individual cells and then you know, maybe replacing them. But it may end up with that. Anyway, I'll continue monitoring the charging, and maybe some of them will wake up. We'll see. After desoldering all the T1, T2 points, just with the soldering iron and with this solder remover, I'm able to lift this connecting card, and looks like it's okay. I'll have to clean the back, but I'm gonna measure all the points and make sure they're still connected. This way I have access to all the connections between the batteries. I'm gonna do the same thing on the other side. Now I'm gonna try to remove this soldering points to expose all the connections behind this connecting thin film. So after a lot of effort and care, this board is also out. Now I can also clean underneath. I will have to check the connections because it's been harder to take out. After a thorough cleaning of the bench, we can continue working. So now, looking at this spot welders, you can see each battery 1, 2, 3, 1, 2, 3, 1, 2, 3, and so on. So I will have to measure every end of every battery to the opposite end, and I'm going to use a marker to mark 1, 2, 3, 4, 5 up to 15, so I know which ones are good. I'm going to make a piece of paper with the measurements. It's not a perfect order, but this is how I marked them. And I made a table here, and now I'm going to mark them on the opposite side the same way so that I don't make the mistake of measuring 2 points thinking a battery is broken, where in fact it's still good and I measured the wrong points. So these are the measurements. Battery 1, 341 volts. It's probably good. Battery 2, nothing. Battery 3, 2.4 is probably good. 4, 153 is a bit low. It may not be usable. 5 is gone. 6, 139, too low. 7, 331, that's probably good. 8, 0, 13, this is probably bad. 9, 135, 10, 112, 11, 301, 12, not good. 13 is a funny one, 734. That normally happens when two batteries adjacent are bad, and it appears the polarity is wrong, even though I measured on the ends of one battery, so I don't know until I take this one out if it's good or not. 14 is 054, is probably bad, and 15 is not good. So lots of questionable batteries. I feel that I should take them all out and, break the spot welding and put them on the machine and test them individually and clean the connectors. So I'll have to think a little bit about it, what to do. So using this needle nose pliers, and slowly I'm ripping off this solder contacts. The reason is twofold. There's no other way to take them out. And also this type of metal is too thick to be resoldered at the end. So I will have to replace all of these things. By taking it out, I will take a picture because it shows the polarity of each battery when I put them back, if I have enough. Okay. So after a lot of work on one side, this piece of plastic comes out, and you can take a picture of the battery's polarity. Obviously they're all in bad shape. And this wire from the meter had to be unsoldered from the top. But this side is okay. I'll do the same thing on the other side, and then I can take all the batteries out. So after a lot of effort, the top card with the two connecting pieces is separated. I left a few pieces because I'm gonna spot weld on top of them, the connecting piece. And now pretty much all the batteries can be removed, cleaned, and they will be tested. Just a word of caution, be careful. This metal pieces are rusted and very sharp, and I cut myself a few times, so be very careful. The good thing about taking all of them out is that finally I will be able to clean up this box thoroughly. Even if I can't use it for this, I'll save it. I'll also take out this measuring element carefully and give it some power to see if the LEDs inside actually work. And I'm gonna clean up all these batteries of all the rust. It's superficial rust, it's on the plastic, so it should go away. And these things in the, the two ends should clean up and polish nicely so that contact is good. So after a cleanup, here is how this ION R2170030T from Samsung look like. These are very strong batteries. I had some before, and I can swear by them. They work in DeWalt, the newer, wider, compact batteries, all sorts. This Flexvolt is basically hard to repair, but some of these batteries, if I can't repair this one, will help me to repair 20 volt max batteries of the newer type, the one with capacity for 4, 5, and 6 amps. Possibly even 8 amps, I don't remember, but 4, 5, and 6 for sure, because I did repair some, and these are exactly the cells that exist inside. So out of all these 15, I have to test them one by one and look at the capacity overall and look at the internal resistance and the maximum voltage and some other parameters. And I have a machine that I can put them in, and it will do the whole testing automatically. Taking out the signs of spot welding and of rust so that the contact is perfect. It's easier on the negative side. This is the negative side, the wider connection, because there is no chance to short with a positive, whereas this is part of the cylinder that goes all the way to the top. That's the negative side. The positive side is this little thing here, and don't stick anything in there because you'll touch this positive with the negative and you'll have flames. So if you want to clean up some of this gunk, use a toothpick. But overall, I'm sure right now it's gonna be good contact. And this is what I used. This Dremel used this way. Gently and slowly, without pressing too hard. You can take all the signs of the old spot welding and all the signs of rust. This is the machine I'm using to test the capacity. It has 8 slots, but I only loaded 7 because this is a higher capacity battery. It requires higher current. I've already tried this 4, and they don't take any charge, and I have 4 more to put in. So this one's, I don't know how to put it because the light is strange. Anyway, they are in different states of charge, these 3. 245 millivolts at 3 volts 46, so this one is perfect. 290 at 264 and growing. 289 at 281. It's around 280, 300 because it takes 2 amps coming into the unit and it splits them by number. It should be 250, but like I said, they're high capacity. So this is 338, 287, 341, 254. So it looks like they're all charging. If you see here, the charging indicator is going up. They're all showing lithium ion. They're all charging. So charging them at 200 millivolts is going to take a long time. So this is maybe a many hours type of job. So I'll have to wait to know the result, what's the maximum charge that they will take. And this box also has a function that's called capacity measuring. So it charges the battery all the way, it discharges them all the way until they are no longer able to discharge any current, and then it charges them again, and it gives you the final result of the capacity. It's not true capacity, because when the current is very, very low, the DeWalt tool will not be able to run with its powerful motor. But it's an indication, and it's the same indication that's written sometimes on batteries that say 4 amp hours, 6 amp hours, 8 amp hours. If you use a tool that measures the capacity, there is no way that those batteries actually have that power. But I guess manufacturers have to write something on the batteries to give you a feeling that this is a 1x, 2x, 4x, 3x, whatever. So anyway, it's a good tool. So in the first phase of testing, I was able to determine that out of the 15 that I had marked in here, I had 7 that were questionable, actually 6 that were bad, but 1 that I wasn't sure exactly. So I was able to determine that 9 of them are actually good. 6 of them I had to throw away. So I need to find 6 batteries to replace the 6 that were bad. And out of the 6, 4 of them were actually 0. They were probably internally shorted. And 2 of them, I tried to charge them, and I was able to charge them up to a certain point. But as soon as I took them off the charger, they started to discharge very fast. And that means internal resistance is huge, and basically they're useless. So I threw away the 6 of them. So this 5, now I'm going to put on the same machine and leave them probably more than a day to totally measure the capacity. And then I will mark each and every one of the batteries with the exact capacity and try to find the 6 matching cells.
Please subscribe to my YouTube channel. New videos will be posted every week. Choose to get notified, and I hope to see you soon.